In this lecture, we will introduce the stack abstract data type.
A stack is basically a list, but there is a restriction with this type of list in that if we want to insert or delete anything, we can only do it in one position. Specifically, we can do it at the end of the list, and we call this position the top of the stack. Now, there are two main fundamental operations with stacks. We have the push operation, which means we are inserting or adding an item onto the top of the stack. And then we have pop, which is to delete or remove the top item on the stack, or we can say it's the most recently inserted element. But we're saying that we can only add or remove to and from the top of the stack. There is a third operation we could have where we're examining the most recently inserted element in the stack, or looking at the top of the stack, and we just call that the top routine. So what this comes down to is, in order to do anything with this list, we're only limited to accessing and doing stuff with the very first or top item of the stack here. If we want to see any other element, well, we really can't without removing stuff from the stack first. There are some special cases we have to consider whenever we are implementing or running stacks. For one, if we try to use the pop or top operation on an empty stack or a stack where there's nothing in there, that's usually considered an error in the stack abstract data type, because if there's nothing there, we can't remove anything, we can't view anything. Likewise, if we try to add something, if we try to push an item onto a stack that's full, it's an implementation limit, but it's not necessarily an abstract data type error. It just depends on how you handle the implementation. Now, stacks are also sometimes known as last in, first out lists, or LIFO lists. The idea with this is that the last item that's inserted is the first one that's removed. An analogy I normally like to use with my students to help explain stacks is what I call the dishwashing analogy. So let's suppose you've been asked or tasked, I guess you really wouldn't be asked to do this, but you've been given the task to hand wash a bunch of dirty dishes. So the plates would be given to you in a single pile or a stack. So if a new dirty plate comes, we're going to add that to the top of the stack. We're not going to have a second pile. We're just going to keep putting it on top of the stack here. You don't put it somewhere in the middle. You don't put it in the bottom of the stack. Likewise, if you're going to clean a dish, well, you're going to take it from the top of the stack. If you try to grab any other plate, you're probably going to knock off the entire stack. You're going to break a bunch of plates. And if you were an employee for that company or that restaurant or something that involves washing dishes, you're probably going to get fired. So the only way that you can actually clean the dishes from the stack is by always taking from the top of this pile of dishes. You can't take it from anywhere else. After you clean the dish, well, you would set off to the side and maybe another pile of clean dishes, but you don't have to worry about that anymore. So once you're done cleaning it, you would grab the next plate on the top of the stack to clean it. Once again, you're not going to grab a plate from the middle of the stack. Now, there could be additional dirty dishes given to you, so they would be placed on top of the stack. But the whole point here is, as you're cleaning dishes, you're always grabbing the plate from the top of the stack of plates. Eventually, if you're doing your job correctly, you'll get to the bottom of the stack and clean all of the plates. And this does assume that you can easily clean all the plates. If you can't, then there's going to be some dishes that never get clean. So that's one of the things with stacks, where you should be able to get to the bottom of the stack eventually. Otherwise, there's going to be some items in there that you're just never going to access. Here's a very simple illustration of a stack. And we can see I drew this vertically, and I think that's the best way to show how a stack works. But the point here is that there's always going to be some element that is at the top of the stack. So in this case, we see that the top of the stack would be 2. This is the only element that is visible in this stack. I cannot access anything else until I've gone through the 2. If I want to access the 4, I'm going to have to pop the 2 off the stack, and then I can view the 4. If I add something else, if I push something onto the stack, that gets placed on top of the 4, and now I can't access that 4 anymore. I can only access what is currently on the top of the stack.